Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Don Congdon, a corporate trainer, and we're going to be discussing encoders. Hey, Don, how are you doing today?
Hi, Cully. Good to be back.
Yes, it's great to see you back, and I think we have a great topic for some of our listeners today, and that is encoders. So hopefully they're familiar with the word, maybe even kind of what they're meant to do. But let's just start at the top. So what is an encoder, and why would one of our customers want to use one?
All right. Well, encoders are really an interesting topic. I find them a fascinating one, actually. There are so many aspects to them. They're really a complicated topic, but we're going to start out with something really simple. What's an encoder? The purpose of an encoder is to give a variable frequency drive, a VFD, feedback when it's interacting with a motor. If you connect a VFD up to a motor and you don't have an encoder and you tell it to run at a particular speed, like 1,000 RPM, which is called the set point, the VFD will have to guess whether it's actually running the motor at 1,000 RPM or not. Now, to be fair, a lot of VFDs are really good at guessing and they get it pretty close, especially some of SEW's newer VFDs like the MoVC generation. But nevertheless, you don't actually have any real confirmation that the motor is spinning at the speed you put in. So what an encoder does, it's a sensor, often mounted on the motor, and it provides feedback to the VFD. It gives you what's called closed-loop control. The VFD reads the encoder, it looks at what it's doing. If they don't match, it makes corrections, and over a period of time, usually a very short one, it gets that speed dialed in very close to what you asked for. So feedback gives you really reliable speed control. You can also do something else if you've got an encoder, and that's positioning. It's almost impossible to do positioning without some kind of encoder. There are a few exceptions to that, but they're not very sophisticated. If you have an application that's got to move a very specific distance or to a specific angle, then you need feedback from the motor to the VFD to confirm that the motor's moved to the right position. So that's really why you have to have encoders if you want either precise speed control or precise positioning.
Fantastic. So it sounds a little bit like the old adage, trust but verify. We're trusting our VFD can do the job, but our encoder is going to be verifying either our designated speed or that we're moving to the correct positions that we want to move to. So that's kind of, I guess, a 10,000-foot view of what an encoder
Yes.
is. So how are encoders used? Is there only one style of encoder, or is there kind of a world of encoders upon itself?
No, there is very definitely a huge world of encoders. There are all kinds of encoders, and that's what makes them so interesting. Let's start with the most common type that you're likely to encounter. It's called the motor encoder. A motor encoder attaches to the B end of a motor. Sometimes you see them sticking out the back of a motor after the fan. There's also a kind of internal encoder that SEW sells that's part of the fan itself. It's really compact. But motor encoders are directly attached to the motor. That's the big idea. And what they're doing is they're monitoring the rotation of the shaft. If it's measuring speed, it's just monitoring how fast that shaft is turning. If they're monitoring position, what they're doing is they're figuring out the angular position of the shaft, what degree position it is in the 360-degree rotation. And from that, the VFD can use that information to work out things like linear distances, for example. So motor encoders are your most common type. You can buy a motor with them built in or attached, or you can retrofit them afterwards in certain conditions. That's your most popular type.
Very good.
But there are a bunch of others.
Okay.
And these are what we call broadly external encoders because they're not attached to the motor. They're somewhere else in the application. And let me give you an example of why you might want an external encoder instead of just a motor encoder. Let's say you've got a positioning application where the motor is driving something that moves like a travel drive, for example, and it's doing it through just an ordinary smooth belt. Now, as we all know, belts slip. And so if you had just a motor encoder and you said, move that belt so many millimeters, you could get in trouble if the belt slipped because the motor would think it had moved the right amount of turns to make that position change, but because the belt slipped, it actually moved less. So a motor encoder would be a very poor choice for a smooth belt-driven application. So an external encoder would be mounted somewhere else, and it would be measuring the position in some way that's unaffected by slip. I'll give you an example, very common one, and that is the laser encoder. A laser encoder is mounted on the part that's moving, in this case, the travel carriage. And what it does, it shoots a low-powered laser beam at a target somewhere else. The light beam bounces off the target back to the encoder. It times the travel time. Using the speed of light, it figures out how far it is away from the target. Now, since the encoder is mounted on the travel drive itself, doesn't matter if the belt's slipping or not, it always knows exactly how far away it is from the target, so it knows its exact position. So that's one reason you might have an external encoder. I'll mention that in many applications, you actually have two encoders. You'll have a motor encoder on the motor itself just so you can get the speed perfect, but then you have an external encoder providing the position. And many VFDs can have more than one encoder connected up to them, and they can do this dual encoder operation. And that's definitely more sophisticated, but it allows you to have very good control that way.
And I know some of our customers definitely have applications that need that 1-2 punch of a motor encoder and an external encoder so that they're really honing in speed and position, and they can't afford those small little mistakes, like you said, might occur on a smooth belt application.
Right. Now, let me just mention a few other kinds just out of interest here. Laser encoders are certainly one type used in linear positioning. Another example is what's called the wire draw encoder, and these are often used in hoists where you want to know how far from the ground the hoist is. And the way these work is kind of clever. If you've ever played with an ordinary tape measure like you use in your wood shop, you know you've got that steel tape in there and it's spring loaded. You pull it out, you let it go, it snaps back in. Well, wire draw encoder works the same way, except instead of a steel tape, it's got a spool of wire in there that moves in and out of the encoder as you pull it. And so what you do is you mount the encoder on the floor, you attach the wire to the part that goes up and down in the hoist, and as the hoist goes up and down, it pulls the wire in and out. And the spool that the wire's wrapped around is attached to an encoder that converts that rotation back and forth into a position, and that tells you how high or low the encoder is off the travel part of the hoist is off the ground.
Very cool. And do we have one more, or is that about all we have in the encoder world?
Oh no, there are just so many encoders. I'll give you one more and then
Okay.
I'll stop. I could talk about these for hours, but people will get bored. Um, think about overhead conveyors that are used in many industrial settings where they're moving parts to specific stations. For example, here at SEW, we have one that I always enjoy watching on our paint line. You see all the gearboxes hanging from hooks, and they're going on this overhead conveyor to different stations where they're painted and coated in different ways. That's a perfect application for an encoder. The auto industry uses these a lot for body panels and things. And the way this one works, it's called the barcode linear encoder. There's actually a gigantic barcode printed along the length of the track. It looks just like what you see on products that you buy in the store. It's read exactly the same way with a laser scanner. And there's a scanner attached to the travel drive, and as it moves along the track, it scans the barcode, which tells it exactly where it is along the track. And then the position control system can move it exactly from station to station. It's a really great way to handle that kind of application.
I mean, that's like you said, it's fascinating, very cool to watch. And I mean, we only went through 3 different encoders, and as you said, there's a world of them. So just dipping our toes in the water, and forgive me, but let's say I have an encoder and I have a VFD. Is that all I need to get this functionality out of them? Or are there some more components or accessories that might need to be handled and dealt with to make sure we get the full functionality out of the entire system?
Yeah, when you have your encoder and your VFD, you're actually almost there. You've got all the key pieces, but there are a few things you have to think about. The first thing you have to ask is, can your VFD support encoders? Many VFDs do. I'd say a very large percentage of SEWs do, especially the C generation, the Movi C products. Almost all of them support encoders out of the box. But you need to make sure that's a possibility. There are certainly some VFDs, especially the less expensive ones, that don't have encoder interfaces and can't talk to one. So That's the first thing you have to figure out. Second thing you need to do is if it does have encoder capability, either built in or an add-in card of some kind, you have to make sure that the interface on the VFD is compatible with the interface on the encoder. There are probably almost a dozen encoder
Wow.
interface standards out there in industry. There are a few that are the most popular, but you need to make sure you've got a match. And again, what I really like about our MoVC cabinet VFDs is they have a multi-standard encoder interface that supports a whole bunch of the most popular standards in the industry. So you've pretty much got a good chance that your encoder will work right out of the box with that. But you need to confirm that. And then finally, you need a cable that connects the encoder interface to the interface on the VFD. And of course, that has to be appropriate. Something else I'll mention again, encoders are a can of worms, but what's becoming very popular in the industry right now are what are called single cable solutions between motors and VFDs, where you have this single hybrid cable that doesn't just carry the power, ground, and brake control anymore. It also carries encoder data. And there are several standards for that out there. SEW's proprietary standard for our motors is called MoVLink DDI. And if you have a MoVLink DDI encoder in the motor, and you've got a MoVLink DDI motor, then everything can go to the VFD over this one fat hybrid cable. And just about all our MoVC VFDs support MoVLink DDI out of the box as well. So those are the big things that you need to get everything working. Beyond that, it's just a matter of configuring the VFD to work with the encoder.
Fantastic. And as you said, encoders are a can of worms. So I'm happy to say this is our first of 3 podcasts on encoders because, like you said, we could sit here for about an hour, but we'll keep our audience on their toes. And we're going to come back on the next episode with a little more on encoders. Thanks for
Okay.
coming by, Don.
Well, thank you so much, Cully. Looking forward to coming back to talk about this topic some more.
Fantastic.